Hello guys, my name is Arun and welcome to my channel. This series is a series of tutorials on Fortran programming. Now, in the previous tutorial we saw how to work with select case and also a cool, in my opinion, a cool program, a calendar trick that you guys can have a look and try. Okay, now in this tutorial, before we look at Fort arrays, which I thought of putting it for the next tutorial, I thought of explaining guys something which has to be told, which I was trying to tell you, but I didn't in the past tutorials. This is regarding formatting, especially print and read statements formatting. Okay, I have a program called as formats.f95 here, and I wrote a little sum of it, and I thought of walking you guys through as to what's going on. This program called as formats, okay, has an integer value, an integer variable, a real variable defined with implicit none, and then it has a read statement and two format statements and two print statements and a bunch of comments. Now I'll go walk you guys through. What usually in a read statement, if you guys notice, in the previous time we used to write read statements like this. Now this star indicates that this read statement does not have any internal format, or it's format free. So the Fortran compiler is allowed to use whatever formats it has by default. Okay, now instead of this star, I can if I write this as 5, this 5 will indicate to read the read statement here that it should follow this format, which is indicated by this number 5. What this 5 is just a number representing something like a serial number or something that represents this format. Now this format statement is for, as its name mentions, it's for giving some formatting for variables and presenting them in the read statements and print statements. Okay, this format can also be used to give some formatting while writing values into files and all, but we'll go to that little later. Okay, and now this format statement can be used for any prints, any kind of statement, like it can any number of times, and it doesn't have to be used only once. I mean, suppose if you write a format statement, this can be used for print statements also. I have already given 10 here. Let me just do this with 5. Okay, so this can be used like this, but the thing is, for one print statement, for one read statement, only one specific formatting is allowed. You cannot give multiple formattings. Okay, there are a few format rules. If you guys notice in this, there are two parameters passed in, arguments passed into it. I'll explain you guys what this means. These are the format rules. Suppose if you have a format like i5, what does that signify? Well, I indicates an integer, so whenever this kind of I comes into picture, it means that we are going to expect an integer value placed, and then this 5 indicates how long the integer will be, how many spaces or how many blocks will the integer occupy on the space for this visual display. For instance, if I give a number like minus 1135, this occupies 5 blocks of space in the screen. This 2135, each number takes one space, and the minus sign takes the other space. Okay, now this statement f8.3 is a representation for real numbers. It's a format statement for real numbers. I'm explaining this with format f5.2. What does it mean is that this f stands for a real number or a floating number, and this 5 actually stands for the total blocks in the field. So we are allocating 5 blocks or 5 spaces on the screen to represent this floating number, and 2 represents the mandatory number of decimal places available for this number that we like to have. For instance, this number minus 21.45 will not work because will not work because, see, this has this has 6 blocks and 2 mandatory decimal fields. How? Watch this. This minus takes 1 block, 2 takes 1 block, this one takes another block, okay, and this dot takes another block, and these values 4 and 5 takes another block. So if you want to represent number like this, instead of 5.2, this should be 6.2. okay, this should be 6.2. So what does this f8.3 means is that you have 8 blocks to represent the real number on the screen, out of which 3 will mandatorily go to the decimal places, whereas one space will be occupied by the one dot, and the other space will be occupied by the sign. If it's a negative sign, it will occupy the negative sign, and the remaining parts of it will be given to occupy the decimal number, the whole number part of it. Okay, now if I were to explain this, okay, watch. Okay, now if I just compile, build, and everything is fine, if I just execute this, it just stands idle. Now, unlike previous times where we just click enter to read values, to enter to send values to the read files, since we have a format, this enter will not do. Okay, we just click enter, nothing, because it automatically assumes a value for AR and goes, so this will not do. Instead, okay, suppose if we try 5 space 5.2 5.4 or something, this will show an error because this space is taken as another value and it cannot be accepted. So what can be done is that, okay, you need a separator to indicate this value is separate from the other. The best separator available in Fortran is the comma state. This is the comma. So what you do is that type minus 5.4 something like that and enter, and see, with formatting, okay, when this statement is used, it prints the state when print 10 comma 5 comma AR is used. What it does is that it prints with formatting, because this string is a part of the format, so it will get printed. And there are like if you guys can check, there will be like 5 spaces here, and then after the 5 spaces you will have the value 5 printed. Okay, and then this 4x, I forgot to mention, this 4x means free space, and this x has to be in caps. Okay, let's just this has to be in caps, and this 4 indicates number of blocks, so x is used for creating free space. Now if you guys notice, after this 5 and before this minus symbol, there will be like 4 free spaces, okay, that is indicated by the format, and this 5.2 ensures that we have 5 places here. See, if you guys notice, one space is for the minus sign, one for the whole number part of it, this dot for the one space for the dot, and 40 for the decimal. Okay, and if this is when the formatting 10 is used. When formatting 5 is used, okay, this formatting 5 states that this number requires 6 spaces. So if you guys just compare with the line above, this thing would be clear. So this with statement occupies 4 spaces, and is quite evident here, and this space occupies another one, and below this F only you will have the 5 printed. So it's giving since we use format 5, it gives 6 spaces or 6 space long field for the number 5, and prints the number from the right. Okay, and if you guys notice here, this will be 8 fields long. This will be 8 fields long if you just compare with the top, and out of which 3 mandatory points spaces were given to the decimals. Okay, one for the dot and other for the negative sign. Okay, and if I don't give any formatting, you see this statement is being printed, but you also see this extra space in the front because this comes from the compiler, and this big space, there's big space and this big space, these are all part of the compiler thing. Compilers uh, you know compiler decisions. The compiler takes a decision to keep a space here. These are all default decisions taken by the compiler, so there's nothing to worry about that. Okay, now if you guys see how you can manage these data, and moreover, let's run this file again. Okay, this time I'll give you guys a different number, something like 525, a big decimal. This is like 7 digits long, and then a format such that 8 5 with a negative sign. Okay, negative 8 5 6 3 2 1 point, a big number. Enter. Look what's happening over here. When I give a formatting like this, okay, initially I gave a formatting with i6 for reading the value. Okay, now if you guys see what happened to this number because of this formatting is that see, I printing this in i5. Now in this, if I were to print this in i5, I'm intentionally avoiding 2 more spaces that are available for the print. Okay, and all. So what it assumes is that it does not know how to print this number. So the value is there, but it does not know how to print the number, so it just gives a series of asterisks. Okay, and then after that it's not able to, because of this issue and because of this formatting inconsistency. Okay, see, this 1 4 is kind of neglected, and this number is being used, so it doesn't know how to take the value. So because this AR is given takes a value close to 0, and when this formatting without formatting statement, when this format print 5 comma a comma AR is used, okay, this is able to locate the first 5 to 6 decimal places properly, and it prints them here. It takes the 6 decimal places properly and prints them here, and then because of this mishap and these values over here, it gets really confused, and it takes AR in a completely different manner. Suppose if you were to print them without any formatting, this is how the value looks. Though our value is different, what we gave as an input, the value that it gets printed and saved in is entirely different. So this is something, this is a kind of a warning you have to keep in mind, that when you guys give a formatting, you should be extremely clear as to how the numbers look like. So it is better that you guys know how the numbers look like before giving them. And moreover, there is just one more format which I like you guys to know. Okay, for that I just need one more real variable, br. Okay, and for this format goes something like this. Okay, now go something like this. E let's say 12.5, some 12.5. Now what does this format has to do? Now I'll just get the value for E along with it, get the value for BR along with it, and then I type BR here, and then type BR here, and then at the end of it I type BR here. Okay, and I have to change this format a little for X. By the way, I think this X is case insensitive, so I think it will work fine. And then E7 the same. I just give maybe a little 13.6, something like that. Okay, no problem. Compile this, build this, run this. Okay, it's waiting. Now let's give 3 values. First should be an integer, so I give like 5236, comma, and I should give a floating number, something like minus 52.45. This is fine. and then a comma, and then I enter this new value, for which let me give a really big answer, something like 1452523 point uh, let's see, 52639. Okay, sounds big. Yeah. Let's see what the problem is. Okay, if you guys notice this carefully, okay, when I gave this number, the formatting got lost when I gave format. See, because this number is like six spaces fields long. This minus 52.45 is 6 fields long, but when I gave a number like when I gave the formatting as 5.2, it did not know how to work with it, so it gives a star. But when I give it to formatting 5, where the to print it, you have like 8.3, which is very good, more than enough to print this. It prints the number properly, and it also adds a 0 at the end. Okay, on the other hand, look at this value, E13.6, okay, or E12.5. The value I gave like 14523.5269. It prints the number in this notation, yes, as if like a scientific notation. What this means is that it means this number is nothing but 0.14525 5235 in multiplied by 10 raised to 5. So this is more like a scientific notation, nothing more, nothing less. Okay, now all you have to do is that when you guys give this numbering, you make sure that formatting is kind of proper. Okay, and this is like more of a scientific notation stuff. This will work fine, I think. Okay, let me just make this 6 so that this will work fine. We'll just compile this, build this, and then execute this. The same example, more or less the same example, 52312, okay, comma, minus 52.3636. That is that's 6 fields long. 1423.563, something like that. Enter. Yeah, perfect. This prints everything fine. And if you guys notice, since I used all 5 spaces, I used this number as I5. Okay, I gave 5 spaces for I. Okay, when I print this with formatting, it takes all 5 spaces, so it just there's hardly any space between the G and the 5. Okay, similarly here, when I print this number, there are like 4 spaces between these two, that's given by 4x, and there are like 4 spaces between this number and this number, more or less. I think it's 4, close enough. This is also given by this 4, and this stays the same, but only thing is that this scientific notation, it also comes properly. Okay, now I'll just write this here again as a note. I'll just write how this goes, something like E12.4 something 5 something. What does this mean? E stands for exponent notation, 12 total number of blocks, and of course this 5, I think it's, let's see, what does this 5 stand for? If my understanding is right, I think hold on, I'll just check you guys on it. Okay guys, I just checked it. I had a few questions regarding this. I was just playing around with it. I found it fine. It's like something like this 5 stands for minimum number of decimal places. Okay, minimum number of significant digits. That has to be saved or printed and all, whatever, that has to be there. Now these formatting can be used for again and again, and there can be several types of formatting. And and there is this one more method with which you can do these formats, and I like to explain that here. Okay, I just print let me just comment this out so that we don't get any issue here. And when you type this, you can also type the same prints format of this line like this. Okay, within quotes write the brackets with formatting, comma, whatever you write, you just write this, copy this and paste this. Okay, and then if you write let's see, if you write a comma ar comma br, okay, br, see what will happen. No, wait, okay, we're just getting a warning that this label is defined but not used. That doesn't matter, but no problem at all. When run this, 5 comma minus 5.2, I can go for another decimal. No, can I? Yeah, I can go for, and then 563.523, something like that. And with this formatting, okay, it also works. Whereas this is pretty much the same as that of format 10. Now if I just want to give you guys a comparison of how this works, I just I just print this again. Now watch carefully. Compile, build and execute. 5 comma 5.2 sorry, minus 5.25, okay, 896.563. watch, they're exactly the same. Similarly, watch, now I just stop this, okay, and I can write the read exactly the same. Okay, all I have to do is that copy and put this in single quotes and give a space and then type a comma ar comma br. This will work exactly the same. Okay, now if I just comment this out, because it will just show, it will throw up a warning. Compile, build and execute. 5 comma minus 5.25 comma 563.896, same. Okay, the values get retained as it is. So this read statement is another way. Writing instead of this format statement, you can also use this star to self format stuff. Now this is another option available now. And to be honest, these are not the only formatting statements available, but for most of our practical purposes, these formatting, the rules that are formatting that we saw here will be more than sufficient. Okay, and there are other formattings. Well, I recommend you guys to have a look at it and use it if you guys really need it. And this itself is more than sufficient. And that's all I have for you guys in this tutorial. And thank you guys for watching, and see you guys in the next tutorial. In the next tutorial, we'll be going into arrays. Thank you guys for watching, and see you guys.